Hello and welcome to Virtual WEFTEC 2020 and the ATI NTEC FilterSmart presentation. FilterSmart is an exciting new application of our time-tested EcoSmart technology involving our underwater ultrasonic interface sensor together with an inexpensive but reliable turbidity sensor. Until now, operators have had to rely on two surrogate measures during backwash to ensure proper cleaning of gravity filters. The first is flow rate, which is an indirect measure of the expansion of the media. The second is time. However, wash duration based on time typically incorporates a factor of safety to ensure the filter is sufficiently clean. But this leads to wasted water and reduced media life. With FilterSmart, operators can directly measure the parameters of interest. The media expansion, which is the direct continuous measurement of the media bed and its expansion during a wash, and turbidity, or the quantifiable cleanliness of the wash water, which requires no factor of safety. What makes all this possible is the FilterSmart media level and turbidity sensor. Again, this is time-tested technology that's been around for over 15 years. The FilterSmart sensor is located just below the top of the wash trough in a typical gravity filter. It's a very simple idea. The ultrasonic sensor measures the media level and the expansion of the media during a backwash. This is important because too much expansion can lead to media loss or unnecessary wear and tear on the media. Too little expansion and the filter doesn't get completely clean and eventually will develop mud balls. The turbidity sensor is looking at the wash water just as it leaves the filter and tells us when the wash water is clean or when to terminate the wash. Taken together, these two measurements produce a simple pair of trends. This graph encompasses a single backwash. Of course, the sensors are working 24/7, but right now we're only interested in the backwash itself. The blue trend is the media level, and the red trend is the turbidity of the wash water. As you would imagine, as soon as the wash water flows past the sensor into the trough, the turbidity will be very high. We only measure up to 50 NTU. We don't really care how dirty the wash water gets. We're just interested in when it's trending clean. At the same time the turbidity jumps, the media level rises due to the flow up through the media. In this graph, there's only about 4 inches of expansion, which represents only about 10% expansion, which is considered insufficient. Also, notice how the red turbidity trend slowly drops with a diagonal aspect and noise or chatter in the trend line. This is because it's taking a long time for those fines to flush out of the filter because of the low flow rate. Contrast this graph from the very same filter during the very next wash when the flow rate is increased to achieve proper expansion. Here, the media expands about 9 inches or around 20%. Note the effect it has on the turbidity trend. See how the turbidity drops quickly and smoothly? This is what you want to see. But best of all, see all that blue space to the right of the turbidity trend? This represents a lot of water that could have been saved. This is water that's already been cleaned once and will now have to be treated again. Multiply that amount of water by the number of filters and by how many times each one is washed in a year, and that adds up to huge savings. Plus, the higher expansion rate virtually ensures the filter is being washed thoroughly and efficiently. That's FilterSmart. Interested in seeing how your filters are performing? Simply go to our website or give us a call and request a free trial. There's no charge, and it's a good bet FilterSmart will give you insights into your process that you've never seen before. Be FilterSmart.